We have a question. It says, a photographer is 350 meters away from a lion and wants to get closer before it takes a photograph. There is water hole in the direct line between the lion and himself. So he moves at an angle of 8 degrees to this line to a better position 200 meters further on. Said calculate his distance from the lion. Now let's see. Let's say this is the distance between him and the lion. So this become photographer and this become what? Let's assume this is the lion. I'm not good at drawing, please. Now, that's for that. And the distance between him and the lion is 350 meters. Now, it covered an angle. Let me just try to get the angle so that the shape will be matured. An angle of what? 8 degrees. An angle of 8 degrees. So 8 degrees should be somewhere here. Which is too small, so I don't want to use that angle. Covers an angle of 8 degrees. And let's say this is 8 degrees. And then this become the new point. Remember. And what did he say? To get closer before it takes a photograph. There was a water hole in the direct line between the lion and himself. So it makes an angle of 8 degrees. This is the 8 degree to the line to a better position. To the line. The 8 degree now happens to be here. 8 degrees to the line. 8 degrees to the line. To the line to make a better position 200 meters further on. So 200 meters further on, this should be my what? 200 what? Meter. And now this becomes the distance between this and this. Now this is a new position. So this can be P1. This can be what? P2. This is the distance it covered using this angle of what? 8 degrees. Now they said, calculate its distance from the lion. The distance is what? Therefore P2 to what? Lion position. Let lion position be what? L. So how can I get this? I already know that if this is 8, this should be what? 82. So here should be 82. Now I know my total distance. You agree with me that this is a perfect what? Vertical line which is not sat. I can bring it down. So this will be a right angle. This will also be a right angle. If this is 90 degrees, then here must be 90 degrees. Now I want to know this. Let me take this as small letter p subscript 1, which is the distance, is present distance from the word lion where he wants to take the word picture. And this becomes small letter L1, small letter L rather, and this becomes small letter, total distance here becomes small letter what? P subscript 2. Now, I want to get this, and this is like this is a right angle. I can use my 8 degree to get here, because this is what? Opposite. This is what? Hypotenuse. And this is what? Adjacent. Remember, using my 8 degree. So I'll have sine 8 degree to be equal to my opposite, which is what? P, let this be capital Q, this line. P 2Q all over my hypotenuse what? 200. And this will give me P subscript 2Q to be equals to 200 sine 8 degree. So 200 sine 8. 200 sine 8 gives me 27.83 watts, which unit? Meter. P2Q. So I can therefore take this as my watts, 27.83 watts meter. Now, if I can get my P1Q, I can easily subtract 350, subtract it from 350 to get my watts, QL. Now, I don't think I need this. How do I do that? This is adjacent. My hypotenuse is known. So I'll simply use that again. Cos 8 degree is equal to this, my adjacent, using my 8. Adjacent, which is what? P1Q all over hypotenuse, which is what? 200 watt meter. So P1Q will be equal to 200 cos 8 degree. So P1Q will be equal to 200 cos 8, giving me 198.05, which unit? Kilometer. So I've gotten this P1Q, 198.05 meter. Now I've gotten this, and you agree with me that yes, it's P1Q plus QL will be equal to the total distance, 350 watts meter. So I'm looking for QL. So QL will be equal to 350 minus P subscript 1Q, which equal 350 minus 198.05. 350 minus my answer will give me 151.95, which unit? Meter. So I've gotten my QL. QL is 151.95 watts meter. Now I'm looking for what? P2L, which I'm taking as P1 if I choose to. So I've gotten this and this. I need this. This is the right angle. So this becomes my hypotenuse side. So my hypotenuse, which is P subscript 2L square, will be equals to this 27.83 square plus 151.95 square, which will be equals to this will give me 23087.7, and 27.83 square will give me 774.51. And if I add up, I'll have 23087.7 giving me 23862.289. And if I take my square root, I will have P subscript 2L to be equal to the square root. Let me just put it here, square root of this. And that will give me 154.474 meter. And to three significant figure, P2L will be equal to 154 kilometer. So my distance here is simply 154 kilometer, which is the distance, is present distance from the word lion. Thank you. Two planks of length 1 meter and 1.2 meter lean against each other as shown below. And here is the diagram. If the angle between the planks is 36 degrees, this is the angle between the planks. How far are the bottom edges of the plank? So this is the distance between the two planks, which is the bottom edges. Let's solve that before we think of our B. The distance between, we have an angle and two what? Sides. The side facing the what? Angle can be solved using the what? Cosine rule. If this A, this B, and this C, then here becomes small letter A. So here becomes small letter C, and this becomes small letter B. So we simply have, from cosine rule, we have our A square to be equals to B square plus C square minus 2BC cos capital letter what? A. We use this because the angle is less than what? 90 degrees. So my B is what? 1. So I have 1 square plus 1.2 square for C minus 2 times 1 times what? 1.2. Cos of my angle 36 what? Degree. 1 square is 1 plus 1.2 square. I don't want to like waste time, so I'll use my calc. So we have 1.2 square. 1.2 square giving me 1.44. So we have 1.44 minus 2 times 1 is 2. So 2 times 2, 4, and 2 times 1, 2. So we have 2.4. Cos of 36 equal 0.809. So this will give me 2.44 minus, remember this, all these are together, please. So we have this times 2.4 giving me 1.9416. So we have 2.44 minus my answer will give me 0.4984. So this A, to remove my square roots, I have to take to remove my square, I have to take square root from both sides. So I have square root of this answer to give me 0.70595. But remember, they said to what? To 3 significant figures. So I have my A to be equal to 0.706, which units? Meter. So this is my answer. So this length is 0.706 meter. So I've gotten the first question. The second question is, what angle does the longer one make with the floor? The longer length here is this. So the angle it makes should be this, which is, I'm looking for angle what? B. So I can use my sine rule to say B over sine capital letter B to be equal to, since I've gotten this side and I have the angle, I'll have my small letter what? A all over sine capital letter what? A. So I'm looking for angle B. Small letter B is 1. 1 over sine what? B will be equals to my A, 0.706. 6. Remember I told you not to use approximated value. Sine, my A is what? 36 degrees. So sine B will be equals to sine 36 degrees, because 1 times 36 degrees will still give 36 degrees, all over 0.70595. And my sine B will be equals to sine 36 divided by previous answer. This will give me 0.8326, and B will be equals to shift sine of 0.8326, which will be equals to 56.4 degree to 0.1 degree. So this is my answer, 56.4 degree. 56.4 degree. Thank you. We have a question on the board. It says, an aeroplane flies due north from Ikeja Airport for 500 kilometers. It then flies on a bearing of 60 degrees for a further distance of 300 kilometers before overflying a road junction. It says, calculate the distance of the aeroplane from Ikeja Airport when it was directly above the road junction. And secondly, calculate the bearing of the aeroplane from Ikeja Airport at this instance. Is a why question. So how do we do that? Let's assume this is the airport. And it flies due north. it flies due north. So here should be straight. .500 kilometers, if I divide by 10, I'll have what? 50 meter in my ruler. 50 centimeter in my ruler. 50 centimeter in my ruler. So this is my 50. So this is my Ikeja airport. Ikeja. Let me use I. So I can take this as, let me put A for Ikeja airport. And this is I, my initial point. And this is my 500 kilometer. It then means after getting here, it moves to this direction. Here is it. It then flies for 300 kilo. It then flies on a bearing of 60 degrees. So let's use our protractor. I don't think this is going to enter. I have to draw this down so that the 60 can enter here. So let me reconstruct. So here's my 50. So we've done the first information. Now the next information says, it then flies from this initial, I move to somewhere else. It then flies on a bearing of 60 degrees for a further distance of 300 kilometer. So let's get at 30 degrees. If I have this here, my 60 degree rather, the top is 0. So I have my 60 degree here. And I can connect. Please use your protractor to do this also, to get a defined diagram. Now mark out 300 kilometers. If I divide by 10, I'll have 30 watts. I'm using my centimeter to represent kilometer. I'll have my 30. So this is my 30. And I can therefore connect this to this. And this become my final point, and I can clean this out because it's not needed. So this is my final position. You can see how cool the diagram is, how perfect it is. So this is my 60 degree. If this is 60 degree, here become 90 minus 60, which is what? 30 degree. And this is a right angle. So I can have a combined angle to be 90 plus 30, which gives me what? 120 degree. This is my small letter I, corresponding to AF. This is my small letter A, corresponding to the airport side, and the angle the airport side is fixing. And this is my small letter F, corresponding to the angle of the final point, final position of the aeroplane. Now they said we should calculate the distance of the aeroplane from Ikeja Airport when it was directly above the road junction. So this is relatively what you are asked to look for, I, which is AF. Now, how do we get it? Remember, this is my A. They said it's 300 kilometers, so I'll put my 300 kilometer here. So, using my formula, I will have small letter I to be equals to small letter A square plus small letter F square. I'll use plus because this is greater than 90 degrees is an obtuse triangle. So I have plus 2AF cos 120 degree minus angle I square. So I have I square to be equals to my A, A is 300, so I have 300 square plus my F is what? 500 square plus 2 times 300 times 500 cos 120 degree, 180 degree rather, 180 degree minus what? 120 what degree. So I'll have my calc. So I have 300 square will give me 90,000. 500 square to give me 250 what? 1,000. Plus I have 2 times 300 times 500 times 500. I can just put my cos 60 degree, and I have 90,000 plus 250,000 plus 2 times 300 times, and put my plus here, plus 2 times 300 times 500 times cos 60 is 1/2, and 2 can cancel 2. So I have 90,000 plus 250,000 plus 300 times 500, which will give me 150,000. So if I add up plus 250,000 plus 90,000, this will give me 490,000. And to get my I, if I take my square root, or have I square root will be equals to 490,000 square root, and square root cancel square root, I will be equals to the square root of 490,000, which give me what? 700 what? Kilometer. Why? If you observe, 700 is greater than 300 and this, because if this is already 120 degree, the two other angles left for the angle would be equal to 180 minus 120, which is 60 degree. So these two are sharing 60 degrees. So this happens to be the biggest angle, so it carries the biggest side. So our answer of 700 kilometers is perfectly correct. So let's go for the B part. Let's go for the B part. Let me clean this top. Now the B part says, find the bearing of the aeroplane from Ikeja Airport at that instant. From Ikeja Airport at that instant. From Ikeja Airport simply means you are looking at the bearing of the final end of the bearing, which is the final position from Ikeja Airport. From Ikeja Airport. So I can take this as alpha, and if so our focus is Ikeja Airport. The angle made between the north of Ikeja Airport till it touch the line that connects Ikeja Airport and the final point become our bearing, which is this what? Alpha. Now how do we get it? To get alpha, A is known. I'm looking for my angle, and I is already gotten, and I know my angle what? I. So I can use my sine rule. I all over sine angle I will be equals to small letter A all over sine angle what? A. Now my small letter I has been solved for, which gave me 700 all over the angle I, which is what? 120 degree, equals to my small letter A 300 all over my angle of A, which corresponds to alpha. So I have my sine what? Alpha. Now if I cross multiply, I'll have 700 sine alpha equal to what? 300 sine what? 120 what? Degree. All over what? 700 all over what? 700. 700 will cancel 700. I'll have sine alpha equals to, I'll have 300 sine 120 divided by 700. I'll have 0.371112, and alpha will be equal to sine inverse of 0.3712, which give me shift sign of my answer to give me 21.787 degree, which is, and we are asked as the bearing. So the bearing is equals to 021 to make it 3 figure first points, and they said to 1 decimal place for the angle, so here become 8 degree. So the bearing of the aeroplane from Ikeja Airport at the instant is 021.8 degree. Thank you. A ship leaves port and travels 21 kilometers on a bearing of 032 degree and then 45 kilometers on a bearing of 287 degree. Calculate its distance from the port. B. Calculate the bearing of the port from the ship. Now let's start. It leaves port. Let's assume, let's say these are ports. Is our port P. Now, they said it travels 21 kilometers on a bearing of 32 degree. 32 degree, remember, should be between what? Northeast. This is south and this is what? West. So let me drag my 32 degree. If I use here, the top is 0 now. So this is what? 32 degree. And I'll draw it very long before I'll take out my distance. (32 degree). Remember this 032 degrees to make it 3 figures for 3 figure bearing. Now the distance is 32. I can multiply it by, the distance is 21 kilometers. I can multiply it by 2. If I multiply it by 2, I'll now have 42, so that the diagram will be a little bit big. So I multiply that by 2, so I must multiply my 45 by 2 also to give me what? 90. Take notes. So this is 42. 41, 42. So this is my 42. So if this is 32, this must be 32 what? Degree. Alternate what? Angles. Now, and then mean it did another, it followed another direction as well. And then 45 kilometers on a bearing of 287. Now, here's 287. 287, this is 270. So 287 should be in between northwest. So if I say 287 minus 270, I'll have the angle made with my west. So I have 287 minus 270. So I have 17 degree here. 17 degree here. Take notes. So using the inner 17 degree. This is 10, 15, this is 17. Take note, and then mean after getting to the first position, it changes course. That's the meaning. Now, this is 90. Let's mark out our 90 using our inches. To convert space, please take note, I'm reducing this. Please take note. To reduce the space, I reduce. To convert our space, I reduce this. Please take note. So get this. Now, we are done with our diagram. The first was 21 kilometers. then 45 kilometer. Now when I checked 287 minus 270, I got this little angle to be 17 degree. Now remember, if this is 32, then here should be what? 90 minus 32. And I have here to be what? 58 degree. Because in between southwest is 90. So if this is 32, here should be 90 minus 32, which give me 50 what? 8. So I'll add up these two angles now. Plus 17. I'll have 75 what? Degree. Now I know this distance, I know this distance, and I know the angle. So if I have two sides and a graded angle, I use cosine angle to find my third side. And I calculate the distance from the airport. And this is the initial point, this is the final point. What they are asking you now, is the distance. What they are asking you now is the distance of the port, the distance of the aeroplane from the what? Port. And that distance is talking about the final what? Position, which is what? FP. FP can be represented as small letter what? I. F can be capital letter F, the angle facing the side. The side can be represented as small letter what? F. And the side facing angle P can be represented as small letter what? Small letter what? P. Now I can get my side easily using what? Using cosine rule. So let me clean this part. I've already seen what I'm looking for. Now, using my cosine rule, or have I can just say I if I choose to, and I'll put everything as square roots. I become what? P square plus what? F square. What's the angle? 75 is not greater than 90, so I'll use minus 2pf cos capital letter I. Now I will be equals to the square root of my p is what? 45. 45 square plus f 21 square minus 2 times 45 times 21 cos 75 what? Degree. Now I will be equals to, or I can just punch this out, the square root of 45 square plus 21 square minus 2 times 45 times 21 cos 75. And I have 44.462 distance, which kilometer, which is approximately equal to 3 significant figure will give me 44.5 kilometer. So this is my answer to my question A. And question B says, calculate the bearing of the port from the ship. Calculate the bearing of the port. This is the port from the ship. From the ship is talking about the final position of the ship. So from the ship, our focus is what? From the ship. So it is the angle covered from the final position, the northern side of the northern side of the north, from the north of the ship to where the ship meets to the line that connects the final position of the ship from the port, which is from here to here. So that's it. The bearing we are asked to calculate for is the what? Angle sustained from the final position of the ship, the northern side, to the line that connects the final position of the ship to the what? Port. Now we can see that this is already a right angle triangle. I can take this as alpha and I'll take this as what? Theta. So my bearing, therefore, I can clean this out. I've told you what I'm looking for. My bearing, therefore, should be the right angle, which is 90 degree here, as you can see, plus my alpha, plus my what? Theta. But alpha is equals to this 17 degree here. Why? This is a perfect east-west. There's another perfect east-west here. If there's a line that connects them, since it's a perfect horizontal line and perfect horizontal line, and this is 17 degree, then here must be what? 17 degree. That's how we have alpha to be equal to 17 degree. Take note, Now I need to look for my theta. How do I get my theta? My side is known, the angle is not known. So I can say small letter f all over sine capital letter F will be equals to which known angle and side again? I is known. Thank God I'm not removed by I from my calculator. So small letter I all over sine of the angle of what? I. Now my F is what? 21. All over my angle F is the same thing as what? Theta. Equals to my small letter I is 44.4616 all over sine. My angle I is what? 75 what? Degree. Now I'm looking for what? Theta. I'll have 44.4616 sine theta to be equals to 21 sine 75 degree. And I'll divide through by 44.4616 all over 44.4616. This we cancel this, and I'll have sine theta to be equals to 21 sine 75 21 sine 75 and I'll have 0.4562, and theta will be equal to sine inverse of 0.4562, which will be equal to shift sine of my what answer, giving me 27.14 degree. Let me verify this again, please. 21 sine 75 divide 44.4616. Yeah, so I've gotten my theta. Therefore, I will have my bearing to be equals to 90 degree plus my 17 degree here plus my theta 24.14 degree, and I'll have 90 plus 17 plus 24.14. 27, is it 24 27? Shift sign 0.454564 27. So I have plus 90 plus 17. This will give me 134.155 degree, which is approximately equals to 134.2 degree, because it says to 0.1 degree. So this is the bearing, and if you observe, this is what we calculated for, and it must be in between my southeast, and 134 degrees greater than 90 but less than 180. So our bearing is absolutely what? Correct. Thank you. An aircraft flies around a triangular course. The first leg is 200 kilometers on a bearing of 115 degree, and the second leg is 150 kilometers on a bearing of 230 degree. How long is the third leg of the course, and what bearing must the aircraft fly? Now, remember, our diagram is most paramount to us. So let's see. Let's say this is a point of which the first leg take off. Now they said the first leg is 200 kilometers on a bearing of 115 degree. 115 degree. If I start from here, this is my zero end, you can see it. This is my zero end. 115 straight is this. So I've gotten this as my 115 degree, or mark out with my ruler. So I've gotten my first leg, and the distance is what? 200. If I divide by 10 or have 20, I'll multiply by 2. So I divided by 10 and I multiply by 2. Take note. I'll have what? 40. So this become my what? My first leg, which I can take as what? F. And the distance is what? 200 kilometers. And the second leg will move from the first leg, remember. And the second leg is 150 kilometers because it moved from this, I'm taking this as a starting point, it moved to the first leg. This is the bearing it covered, and this is the distance. And the bearing is what? Here's the bearing, 115. If I say 115 minus 90, I'll have this smaller angle, which is what? 25 what degree. And if I say 90 minus my 25, I'll get here to be what? 65 what degree. Now I've got to my first leg. Now let me try to get my second leg. My second leg says it moves at a distance of 150 kilometers on a bearing of 230. 230 is greater than 180, then less than 270. So it talks about the southwest this time. So 230 minus 180. 230 minus 180 will give me this as 50. If I get here as 50, then here become what? 40. So let's draw it out. So let's get 50 degrees. Let me use here so that it will be easier. So I'm starting from 0. This is 50 degrees. So I'll put my 50 degrees there. Here's my 50. 10, 20, 30, 40, 50. So this is my 50, the top one. So I'll therefore rule. And I'll rule it very long so that I can mark out whatever distance I choose to mark out. Now I've done that. The second is what? 150. So 150 divided by 10 will give me 15. Times 2 will now give me what? 30. So I'll mark out 30 so that my triangle will be reasonable. So this is my 30. You can see it here. It's my 30. So therefore, this is my second leg. Second leg. Now I can connect this to this. You see how perfect it is. If I have not done this, I wouldn't have gotten it this accurate. You see how accurate it is. Now I can put all my silent words information. Now this is alternate to this, a perfect northwest. So here must be what? 25 degrees. And you agree with me that here will be what? 65 what degree. Though not needed, the top is not needed here. Now, the second was what? The second was what? 230. And here was what? 50. And here become what? 40. And if I add up, I'll have what? 65 what? Degree. And the second distance is what? 150 kilometers. Now they ask us, how long is the third leg? So this become what? Third leg. Third leg, which can be taken as t, while this can be taken as second, which is x, and this is first, f. Now they said, how long is the third leg of the course? The distance of the third leg is what? St. So I can have st square to be equals to my distance, this is my angle. I'll simply have what? 200 square plus 150 square. This angle is not up to 90, so I'll say minus 2 times 200 times 150 cos 65 degree. And my st square will be equals to, I'll resolve this once please. 200, you can write it as I'm saying it, 200 square plus 150 square minus 2 times 200 times 150 cos 65 degree, which gives me 37142.9043, and st squared, I'll take my square root to remove it, and st will be equals to the square root of what? This. And the square root of that will give me what? Will give me 192 to three significant figure will give me 192.725. So to three significant figure become 193 what? Kilometer. So this is 193 kilometer. So the distance the third leg will cover is what? 193 what? Kilometer. So we've gotten our first. The next we are asked, here's my duster. The next we are asked is, on what bearing must the aircraft fly? How long is the third leg, and of what bearing must the what? Third leg fly? So let's see. The bearing this third leg is going to fly is this. Is the bearing of the third leg from the first leg. The bearing, let me write it out. The bearing, the aircraft must fly is the bearing of the third leg from the second leg, and that should equal. Remember, from the second leg simply means we are focusing on the second leg. So is the angle covered from the north of the second leg till it touches the line that connects the third and the second leg. So our angle must be greater than 270 degrees. Why? This is west, which is already 270. So we can take this as our theta, and let this be our what? Alpha. You can see that using your protractor and your ruler to draw, you get all your information so visible. Now, if you watch this angle, if I have a if I have a northeast and a north south and a north south, and I have a line here, this angle must equal this angle. So you see, if this is alpha, then here must also be what? Alpha. The two angles must be equal. Now, this 65 degree put here won't be used because it's the remainder from what? This line till the certain position. So I need to look for this my angle theta. If I get theta, if I can get my theta, I know that southeast is made up of 90 degree. I will say alpha plus theta plus 25 will be equal to 90 degree. And if I get my alpha equal this value here, then I can simply say alpha plus my theta also equal to 90 degree, and I'll make theta as a formula, and I'll add it to my what? 270 what? Degree. Now, let's start. Let's get our theta first. To get our theta, we can see that this can be small letter t. This can be small letter what? X. Let me clean some parts so it won't be confusing. Let me clean this part since we've gotten it. Now, I can clean this now because I've already explained what we have to do. Now you can see that I'm looking for theta. So I can say small letter t all over. Let me write my bearing first. My bearing will be what? My bearing will be 270 degree plus my what? Theta here. From the north of the second till where it connects what? The third and the second leg, which is 270 plus this little angle here, theta. I'm taking this my little angle here, get me right. This little angle here, this angle, bigger angle here to be what? Theta. So my bearing will be 270 degree plus whatever I get as what? Theta. So let's start. No, I can't use two values at the same time. If this is theta, then let me use this as what? Alpha. So if this is alpha, did I use? Okay, yeah. This is alpha. So here should be what? Plus alpha. Now, let me get my theta. So I can say T all over sine capital letter T to be equals to which other angle and side is known already? Yeah, my small letter f is known. Small letter f all over sine capital letter what? F. Now my small letter T is 150. 150 all over sine. My capital letter T is same as what? Theta. Is same as theta equals to, my f is what? 193 kilometer. So I'll use the exact value. 192.72, let me say 5. All over sine f. My f is what? 65 what? Degree. Now I'm looking for theta. Or simply have sine theta to be equal to 150 sine 65 degree, all divided by 192.725. Now my theta will be equals to 150 sine 65 divided by my what? Answer, which gives me 0.7054. So theta therefore will be equal to the sine inverse of this value, 0.7054. So my theta will be equals to shift sign of my answer, giving me 44.86 what? Degree for my theta. If that's my theta, we should know that, like I said earlier, alpha plus theta plus this 22 degree, 25 degree rather, will equals to 90 degree, because they are all formed between southeast, and the angle for southwest is 90 degree, which is the right angle. So I'll have my alpha plus my theta, which is what? 44.86 degree, plus my 25 degree will be equals to 90 what? Degree. Now I'll therefore have alpha to be equals to 90 degree minus 44.86 degree minus 25 degree. And alpha will be equals to 90 minus 25 minus my answer, giving me 20.139 degree. So I've gotten my alpha. But remember, alpha here and alpha here, they are what? Let this be phi, please. This should be phi, so it won't confuse you. Yeah, phi. So phi now is what? 20.139 degree. But phi is equal to phi, like I told you. This forming a z, so phi is equals to phi. And phi plus alpha should be equal to 90 degree. You can see it. The angle between north and what? West. Now where am I writing this time? Okay, let's use here. Phi so phi plus what? Alpha is equals to 90 degree. Why? The angle between what? Northwest. So I'm looking for my alpha. Alpha will be equals to 90 degree minus what? Phi. And this will give me alpha to be equals to 90 minus 20.139 degree. And alpha will be equals to 90 minus my answer here, which gives me 69.861 degree. So I've gotten my what? Alpha. Now I can simply say my bearing, which equals 270 degree plus alpha is equals to 270 degree plus 69.861 degree. So if I add 270 to this, I will have 339.86 degree, which is same as to 0.1 degree will give me what? 339.9 degree to the nearest 0.1 degree. That's my answer. And